I know, but
good to
it's
know.
like,
Couple tidbits from yesterday. I forgot an entire section of standards. Where is he? I think you showed me. Somebody who showed me about the IRO standards for things that anyone know what IRO is?
I have no idea.
It's what the RC does. So RC, all that stuff, and there's tons of transitability in there that they're running all the time. So my mistake. I learned something yesterday. It's a bunch of these standards that TS is used in, and RC guy came and said, yeah, we do a lot of that. Anyway. Composite load model, I remember when that first came out, it broke a piece of software. Remember that? Because this one's, I don't know if they're still bus limited, but I know that now I'm doing studies in the East. They equivalence almost everything because some software tools can't handle the number of buses. And the load model, when it was instantiated, right, it creates some buses and just pummeled that thing. So you can be thankful that we have a piece of software that actually can function when you turn composite load model on and will become bus limited.
Yeah, there's two versions of PSLF, a 40,000 and an 80,000 bus.
Or that, because PSSC's got the same issue. This was an Eastern interconnect, and those guys all,
PSSC is, I
they
mean,
freaked out.
let's just agree they have a lot of issues.
Yeah, but they also, their cases are 4 times bigger.
Oh,
So
they're
they get
82,000 buses
Yeah.
in their base
On the-
case
in the
before
east.
composite
Yeah,
load
in the
model.
east.
So we're gonna do
But not
this.
as
They're messier, that is for sure.
And it was just a discussion, again, some of you, we'll make sure we're done, but I was gonna ask, because almost all of us who do studies, maybe not all of us, we'll save the case now and again when you get one that's real squirrely. So I have a couple of cases that were published, they were WEC approved, they were Palo versions, and you open them up and they don't work. And here's what do you do. Now you're an anomaly because you have an amazing institutional knowledge here. So I don't know if any study engineer really struggles here because you can always ask 20 of your other study people, what's wrong with this case? But for the rest of us, for a lot of utilities, there's one poor soul slob out there.
They still
She's just
struggle.
crushed by this one case. And we can run to Jamie right away, or we can, I'm gonna skip that one. So let's just open a case that won't initialize, and we'll go through some steps that we have all learned, and you might even suggest some steps that you go through. In fact, let's do that. You get a case, I'll just open it. I'll show you what one looks like. This one was on a study not too long ago. Where are we at? WEC.
Richard, is this your stuff?
This is my stuff.
Not in this training stuff?
No, I didn't get these out there, which is, I was worried about it, it was just too big. And I have NDA for all this stuff, so we're good on that. These are all WEC cases.
These are
But-
all WEC members, so I'm not worried about here, so.
This is what can happen. And let's just discuss, well, what do you do if we get this going? In this case, so and what are the first steps that people do? For those of you who don't know, who are just starting out with this, and you get tasked with running a system impact study-ish thing for some customer and wants to throw a generator on your 500 kV. I don't know if you get to do that, but you get a TS case. What's something that all of us do initially? Can you name off a couple of things that you have learned in your experience that you should do before you actually get into the guts of running a study? So yeah, flatline, right? What is it? Who said that? What is that?
10 points.
What's that?
No disturbance.
Run it until with no disturbance to make sure there's not things that are way out of limits or just bad
Something-
that cause
Yeah.
a wiggle. And then you got to net out a bunch of generators, don't have models, and now I know there's a dashboard for this.
Right. So you run a flat line. You define a contingency with nothing in it, and you start it, and you plot some stuff. And what you want to see is just, and what you'll sometimes see is not that. So like Tom was saying yesterday, we all start ours at a second. That's been I think Grid started theirs at like -1 second, and then they would kick the transient off at 0, right?
I never understood.
Which was different, but it still gives you a second of a gap, which is also really best practice. Make sure you put a second or so before your fault so you can see, did this case have any issues before you got started, right? Another thing when you do a flat line is sometimes you'll get plots that are crazy, because I won't show it here because Power World auto scales. So your frequency, you'll see frequency doing this. Well, the scale is 60.00001 hertz to 0002 and down. Well, it's flat. We've seen it. We've all got caught by that. We've seen lots of people go, "Oh my God, what is this?" And it's flat. It's just looking amazingly close. So yeah, run a flat line.
Yeah, another thing, people, the support call I get where it's like this. I'll get a plot. It's like, what's wrong with the simulation? And it's like, this right here is about 0.01 megawatts, and that's like the solution tolerance of the power for the network equations. So it's like, just don't email me about that. It's like, it doesn't mean anything.
Flatline, and then there's double Palo Verde. I know Columbia Grid had a list of like 6 outages in the west that got stuff to wiggle, and you expect it to damp. And we've all likely learned the hard way that if you don't run those and you spend a couple of days wondering why something's broken, you should have gone back and ran that in the beginning to find out your case wasn't stable. And don't be surprised, WEC published cases, even though we do our best with some of this stuff, something magical happens sometimes in a case. When it gets published, you get it, you run it, and it's broken, like this. So this one is, we're just gonna run this nothing thing, and hopefully it, yeah, we get this crazy, I don't know how to make that bigger. But in the log, I'm a big fan of the log. You should become big fans of the log. You don't get a whole lot, I'll make that bigger, other than it was really unhappy. On the status bar, this is where, I don't know why these are sometimes disconnected, but they are. Sometimes these don't show up in the log. This text.
Correct, that won't necessarily show.
So it's good to, if you've not paid attention to this little bar up here, for this particular case, this is where the action is, because it's not in the log. Even though the case won't initialize, it's all been validated and run, there's something funny with this case. So if you had this, what would you do? Experienced planners, what might you do? Yeah, go to the bus, right? Let's go.
So wind turbine.
Well, it's Wild Horse, right? Anybody ever had Wild Horse freak a case out? Okay. What's the wind plant in, honest to God, it's happened more than once. There's a wind plant on the battle line in Montana. What is that? No disrespect to, where's the camera? No disrespect to you guys, but Glacier Wind. There's a wind plant called Glacier Wind, and gosh dang it, that model, for whatever reason, it can unzip a wet case. Like it can punt Alberta, we've had that thing just freak out. And because as planners, I don't know what to do with those parameters, I just disable the whole model. Right? That's what I can do. Because me going in there and changing it, let's say their inertia is just some mad number. Well, I know what inertia is, but it's no better when I changed it than it was in the first place, to be honest. So there's nothing wrong with punting that stuff. But this one's a good one, because this actually happens. So 42372, let's mosey on over. So I've learned this is sometimes bad, that a generator is online and it's sitting at 0, right? And I'm not.
The software should catch this if it's a problem. I'm gonna write this down. You're right, it could cause numerical problems.
Well,
That
you know,
happens to
and then
me.
you go, you'll learn this stuff. We go to generators, we go sort on megawatt, and if we get out of the whole motor area, there's a number that are at 0 and that are on. Now, the software people, why is that a big deal? I mean, it's a big deal in this case because this is the problem. Go ahead.
The not a number stuff can happen in the numerical calculation. Something ends up being 0 divided by 0, and that's probably what's going. It's a bug in the software ultimately. So send me this case and hopefully handle it more gracefully.
Yeah, if anybody wants to know.
But
I mean,
that's the kind of error where you get undefined power mismatch. That's what's going on.
But what if it was a synchronous condenser?
Well, but it wouldn't normally be at, I mean, the point is we need to capture. It's at 0 though. Would a synchronous condenser be at 0? Yeah,
I think for power it would be 0, but it could generate VAR.
Yeah, so anyway, there's something in the equation.
So, 2021 Light Spring 1, that's the one punted on. So, what do you do?
I would go look at the generator
What's a thought?
I just wanna bring up another point is,
Yeah.
not just zero, but when we run transient on the real-time cases, condensing doesn't work either. You have to turn those models on. And zero, well, there's a lot in the real-time cases where there's zero connected, and that'll cause problems
Yeah.
in the case.
So light spring, you know, could the wind be blowing? You know, it could, but as a planner, I just want to I want to use this case. This is the case I want to use. This is a public approved case. I mean, it's a WEC approved case, so.
For this one, I would open up the generator and the feeder network and then close them in one at a time. to see
An
if I
option is just open it, right? And then, good enough option, I don't think it's Easter egging. And then we roll over to stability and honestly, try it again. And I think this one fails again, because all the wild horse is unhappy.
Wild horse wind plant.
Yeah. I think it's gonna punt, yeah. 42, 367.
Stack com model, the problem.
I like
W1.
I have Jamie, I have a question. So I'm kind of doing the same thing that he's doing, and I am grabbing some errors here. I have to go to the bus view and then type in the number. Is there a way that there's a lot of, unless you're in the case information, you can't go see
Right
it.
click and go to
Any
bus.
edit box like that, there's not, we'd have to, I mean, the answer is we could, but we'd have to code it on every
Number
little
two
edit
now.
box, whereas
Yeah.
in the case interface, it's all kind of built in.
369.
So right now it's hopping around.
All the wild horses issues, it looks like.
So can you open that generator and show me what machine model is there?
Open up.
Oh.
And-
It's an induction motor model.
Well, and the cool thing is, this is not an old case, right? This,
Can you
I,
initialize
2017.
an induction motor at
Huh?
zero?
It said
when it was
2017.
built, well, it's not terribly old.
I would never use this case.
Oh, no, this one, I saved this case because I knew, in my time as a
Illustrative.
planner, I mean, I wish I would've saved all of them that I got from WEC. And I looked back and I was trying to think of, I've had some issues where there were some cases, so I just pulled these ones, but these were published cases, so.
Yeah.
It was, yes, it was published in 2017, but it was an honest to good case that was built for us to run studies on. And sometimes it's a translation between GE and PowerWorld. I've had that happen. I had Simrit sent me a couple cases, a coworker, she's a PG&E, that didn't work. They weren't well behaved in GE, and I loaded them up in PowerWorld, and they're well behaved. And I know that we've learned that a long time ago, there was some initializing of some generator current that was done differently in GE and PowerWorld. And initially, the folks at GE said, well, PowerWorld's doing it wrong. And I think you worked with some older gentleman at MVWG, and we found out they're different, but they're both legit. And in this particular instance, between GE and PowerWorld, one of them just refused to initialize. And you're the one sitting there doing this stuff. The good news for us, you'll go through this. We'll fix this because I think that fixes it. That fixed it, right? So, punt and Wild Horse fixed it, and we're in the game. And Wild Horse was sitting at zero anyway in my studies in Montana, so who cares what Wild Horse is doing? And I don't feel bad about using this case after what we just did. So that is one way sometimes you can look up in that status bar, again, because I'm a big fan of the log, but I think it was this case I learned on when it happened, oh, that status bar doesn't show up in the log. But that's where the game was, in the status bar. Questions on that one?
Question on that one. I lost track of the wind model development, because they're getting better, it seems like. But at some point, there was a situation where if you had a wind model on, there was like a wind power factor in the model, and if you were below, like say the wind was on at like 20% or 15%, it would try and ramp it in the initialization, because we can't be there if you're assuming the wind power factor is 1, and therefore we can't pan the blades enough to get down to that level of power. So like it had a conflict. Is that still a thing?
Yeah.
It is, okay. Because I'm trying to, I mean, I think our grid modeling group has decided all the wind plants should be turned on at about 30% at a minimum, so that we can flatline test the cases and get these wind models better.
We didn't decide that.
Oh, we didn't?
You asked for that.
Yes, I am. I thought you guys agreed.
We agreed. We didn't decide it.
Okay. You guys were
And we did.
very gracious.
We built, yeah.
So,
Assume the old building's old, 50%.
Subtle difference, right, Lucas? Subtle.
Well, isn't that good news? That's still a problem.
I'm not making decisions like that for them.
Well, when in
James
doubt,
can.
at least for me, I'm sure you, I mean, you have a lot of senior study people here that you can probably go to. I'm guessing that hopefully happens a lot, because good grief, in this room, you've likely seen everything as far as what a case can do. But I have found Mark at Power World, he'll get my email, and he'll ship it off to somebody, and they'll help you out. If you've expended yourself on trying to get a dang case to function, I'm not saying blow a bunch of email these, but they are quite helpful. And
Yeah, no, I always tell our customers that as a lot, our power engineering brethren are pretty passive people, most of us in this room. And most of you are afraid to bother me. And so you don't tell me when things are broken. So I tell you, for the sake of all those other people who will never email me, get us to fix it so that they don't have to be in the same boat as you. You know what I mean? It's like,
support at
Yeah,
powerworld.com
support, yeah.
is your good friend.
yeah, or
Really?
email Caroline or me or on.
And Caroline doesn't you've met Caroline, she doesn't package anything. She's kind of direct, like, look, it hurts a little bit, but you get going. Here's a
Right.
funky one. This case worked one day and not the next. And I did send this one to Powerworld. Sometimes when I'm lazy, I'll use a generator instead of a cap to figure out how much capacitance do I need there. I mean, I run the QV curves are always short because the volt's always low, but maybe it's a bad practice. I did it this time, and because the client was trying to figure out where's the cheapest way to put a cap back. And so sometimes I'll just go to edit mode, and if you didn't know this, you can go to edit mode and drag this thing over here, and Powerworld will say, hey, you want to move it? I'll say, yeah. And this time I just put one of each, and it lost its mind. And this one's kind of exciting, because I still don't know what the deal is here, but two things that can happen. Let's look at the log, because this was a solving case until a moment, and I'm not pointing any fingers, not doing anything weird here, so go to solve it, and it will, oh, for crying, there we go. It will progressively get worse, okay? And I couldn't figure, to the point where power flow did not converge, right? So here's a good one,
I'll
and
fix it.
just for our, we'll just open this up again, just for our edification, simple thing, I'm gonna solve it once. Here's the tricky part, which is kind of exciting, but I'm gonna open this thing, because this is where the issue is. And I'm gonna solve it, and all of a sudden, I get megawatts from nowhere.
And a 2.7 per unit.
Right? So, this is,
Hey, wait, send me that case.
and I was way confused about this one.
Yeah,
I
just
think
send me
Colin,
it. Like
we're,
right when you get done, as we go to lunch, send it to me, I'll look at it.
yeah. Now, the initial response, but you'll get this, and that's why you save often. If you're new to studies and you make a change, save that case out as something else, because sometimes there's no way to get back. Like this version right here, I have tried, which is something you can do. Often you can do this. You can go way up and open everything up, and then just try to bring it back, right? But this one, this particular line, I've never seen a QV curve at the bottom that was so close to, it just has no reactive margin. So that could partially be it, but I couldn't get this back. I had to start over again, because the math, something happened so badly in here, I couldn't get this to work, enough to even get stability started.
In a lot of our state estimator cases, when we pull one and we take outages and solve, sometimes stuff like this will happen where you just get tons of megawatts or bars going every which direction, and it makes zero sense, and I just close it and start over.
Yeah, and I saved this one because it was like, oh, I got it. I got a good one for someday. I didn't know why, but and it could have been that I used this generator to regulate.
That's why I was wondering what's the regulation.
They weren't both on at the same time. They never were. But I would use this one to regulate this one to 0.95 and see how that worked. And then I would open this one up, turn this one on, use this one to regulate this to 0.95, and just see who was needing more.
Well,
And
there could be a large impedance.
but they were never on at the same time. And then we get this where I'll tell them both off, and all of a sudden I'm getting magic megawatts. And this was also a published case. I'm like, well, gosh dang it. Now this is something I did. Granted, I added a generator there, but it seemed not so terrible. And you'll find that. So that's another way you can. We've saved cases before, not in this one.
Is this reporting a successful solution?
No, it's.
No, it's
Oh, okay.
I don't know how to make that bigger. How do you make that bigger? The log.
There's a font.
Yeah, just skip it, but it didn't converge. It hates line.
Oh, I've seen ones where they converge.
Yeah,
And
but you have some crazy
and
like.
It converges at 0.2 per unit and is happy, yeah.
Yeah,
Or
it's,
like really
it's,
high
yeah,
voltage.
it's solved to a low voltage.
If you're not like
And does that.
We'll get out of here right quick, but I wanted to make sure that, let's see. I thought it was important that we do that load thing, because I was learning a lot there too. Status line, case of WEC data check. Anyone ever use WEC data check?
Handy Auxmal. So if you have a case it's a bit like the SAD metric that Lucas was talking about, but it's available here in the tool. So I don't know if it's going to work in this case, but if you go to case information, this guy, and you roll over here and hit data check, this may have it in it already, but I have an AUX file that says, I don't have it here. So let's load an AUX file. And I don't know if this thing's available everywhere, or is this, where is my WEC data checks thing? Is that?
I don't think I put that in there, no. It's on Power World's knowledge base, if you look up data check.
We're at lunch. I'll get you this after lunch. There's a way you can, it looks a bit like what Lucas was, but you can have it in the tool and you can find out what transient stability parameters does this case hate right now, and it's all in a handy spot for you. Let's pull this one up. And then we'll do 5 minutes over here. Does Bonneville, I'm curious, does Bonneville have so anybody familiar with the transient stability manual that Bogong wrote for Grid like a couple years ago? You should, if you're fairly new to studies, it's a pretty nice document. It's available still on the web while Grid's still alive, but just search on Columbia Grid Transient Stability Manual, and you'll get this manual that Bo put together, and there's some information in there about what do you do when a case just loses its mind. And there's some really helpful steps in there. One of the things that Bo does is he does that awful thing of aborting if there's anything limit violating. But because I think Bo knows what some of those parameters are, I have no idea what those parameters are. I know Pmax, and I can fix some Pmaxes, but
Let me see if I can get this one to give us that data check. Real quick, just so you get a look at what this looks like. Yeah, so there's, I don't actually know what all the, it's a huge, you can look for a whole bunch, oh, I think I have it filtered. Sorry, 1 second. Let me turn them all on. Let's go back to this.
so over here is what facilities do you want? Again, it's very similar to what Lucas showed you, but you can do it on your own. And I don't know who wrote that WEC aux file, but I can make it available because it's just an aux file. Okay,
And
so-
I took the SAD Excel sheet and.
There's some good stuff in here that would sometimes point you to an area of bad news. And you can scroll through here and it will give you an idea of those TS, like Pmax is bigger than, or the megawatts out is bigger than what you had in TS for Pmax.
If you look at the generator, if you drop down, so like min, so let's uncheck all this.
Which one did this one have?
So here's one where Pmax is bigger than the megawatt cap of the turbine. So it's
And that's bad for initialization?
It could be.
It could be?
Yeah, it's not necessarily wrong, but it just might be.
Yeah. So that we'll get that file out there somehow, the aux file, which it can be useful. It's another step that you can, when you're pulling, I can't pull any hair out, I got none left, so I want to get to this solution quickly.
And that's been helpful. We're going to skip this one. This was, oddly enough, what is this case? This one is, so last summer, 2019 Heavy Summer 3, there's a Wanapum unit, one of a number that refuses to damp. And I saved that case because I used the 2-bus thing, the SMID 2-bus thing, just to see, okay, well, what I don't know what those parameters are, but Grant wanted to know why is this thing not going away? And I know those units are frisky sometimes, but the parameters on that one, for example, you add the exciter and it gets worse. So I just played with models. It's got all the things modeled, and I took it down to the machine, and I expected the machine to go and stay undamped, and it did. And I think when you add an exciter, something's supposed to happen. It got horrible. Turn the exciter off, add the governor, things get better. So what do you tell the person? Which standard should the planner ask for to check those parameters? Anybody know? Because all those model parameters come from somewhere, right? Where are those model parameters? Machine, governor, exciter. What NERC standards?
Mod 26 and 27.
Yeah, the mod standards. So every 5, now 10 years, that's supposed to be where I got that data from. And my guess is, since most of us still do this, somebody typed something and missed a number. That would be my guess. That generator test report will tell you, use this model with these parameters. And at least at my time at Avista, we were hand doing that because sometimes there were faxes of chicken scratch. And you'd go, oh, this is that exciter with these parameters. And oftentimes in WEC, it's a typo. But that's not my job. They have to go back and look at their generator test report to figure out what that is. Yeah? And that's, you'll have that thing too. If you're new to this and you have modeling issues, that's a place I always went first was, do I have the right models and parameters? Yes, sir.
And John Andre has a data technical checks for outliers and certain parameters. Now, kind of need to really understand the models and just think that it's very better, but those kind of check for outliers.
Oh, that's
a lot of
nice.
calculators that I've seen have results.
It's helpful to know the parameters, but a clod like me, as long as you tell me, put this number here, at least I can check it, do the grunt work, and I'll send it off to you to do the expert work. And we found stuff before that was transposed wrong. And I mean, there's a lot of data. Let's see, let's get out of here for some lunch. Status stuff, we're not gonna do that one. I had some notes, gen dialogue, model and use, generator.
We can go through it after lunch. Like going through this SMIB would be good to show people.
Go to the SMIB?
That'd be good. Yeah.
All right, well, this case, let me see if I still have it. Let's
Even
get
just
out of here.
showing.
So this was the case that just, the thing kept ringing, and one thing I know, it was during an annual assessment, right? You run this stuff, and at least for me, to check damping, I don't know how Bonneville methodology to prove positive damping is. Do you have a defined methodology that says, I mean, PJM, they have a calculation. Avista and me, I print JPEGs, and I do this, right? The standard says the power has to be damped. That's what the standard says. I think it's a WEC criteria that says positive damping for generator power. So in the assessment, I'll plot out all the power stuff and get a coffee and just and go to the JPEGs. I mean, it seems kind of cloddish, but I don't know of I don't have time to do calculate. So,
Tom and I will have some discussion of that later.
oh, brilliant.
This is all automated.
Well, it's getting,
Yeah.
it's getting there.
I got really good tools now.
But this
But-
particular one,
But maybe he likes that part. He didn't want it automated.
I like
Yeah,
coffee,
that's
right? Right.
Yeah.
No, Richard, we can do it after lunch. I want you to go through this.
Okay, so we'll do it.
Definitely.
We'll go to lunch and then we'll just take 10 minutes to go through what might you do, or how might you direct generation to look into something using the 2-bus model. Cool.